Hello and welcome to the Daily Space Puppy Edition. This is Stella, who is cutting her head off on the green screen at the moment. She came in just as I was about to go live, scared to death of something, needing to be picked up. I will set her back down in just a moment, but I figured I'd share a little bit of puppy with all of you, because let's face it, who doesn't need a puppy on a Monday? Who does not need a puppy on a Monday? Okay, she's just going to lay down on my desk. All right, so hello and welcome to the Daily Space for today, February 18th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. This show is part of CosmoQuest, and we are your place to learn and do science, sometimes with puppies. Puppies who are randomly scared of unknown things. But the reason we are actually here has nothing to do with squirmy, wiggly furballs. Rather, the reason we are here today is science. And let's get to the news. So in today's top story, we have a tale of tidal tales. This is a close-in picture of the Hyades cluster. When you look up the constellation Taurus and see that big burnt orange eye, reminding all of you that Taurus is a longhorn, it turns out that that eye is marking one corner of the Hyades star cluster. This is a cluster that is one of the older ones that you can see in the sky and one of the hardest to spot. And the reason it's so hard to spot is its age. Open clusters of stars are systems of anywhere from hundreds to thousands of stars that all form together out of the same cloud of gas and dust. When you look at the Orion Nebula, you are looking at a star-forming region on its way to becoming the youngest, newest, easily seen from Earth open cluster in our skies. Now, over time, as these open clusters orbit round and round our Milky Way, the slight variations in distance from the center of the stars cause the system to stretch out and become deformed. The outermost stars slowly lag behind as they orbit slowly, and the innermost stars, as they race around the galactic center, they race ahead of that open cluster system. This has long been understood from a dynamics point of view, and looking at the Hyades cluster, we've been able to see with the most well understood stars how this is happening. But what we are now able to do, thanks to the Gaia spacecraft, is look at this system and not just see the easy to find stars as part of the Hyades cluster, but now we can actually trace out a tidal tail of approximately 500 different stars that span a distance of 650 light years ahead of the Hyades cluster and behind the Hyades cluster. These tidal tails mean that as we look at systems of stars, we now know that we have even a better chance of saying this star came from there and this star came from there than we ever knew we had before. This is all possible thanks to the Gaia spacecraft. Gaia is a special kind of orbiting observatory that, as it goes around our Earth, takes not just images, but rather it has a scanning system where, as it observes the sky going by, each pixel shifts down with only certain things being... Am I no longer streaming? So Canada Kim is asking, is everyone still seeing Cosmos? Okay, sorry about that. I'm glad that it wasn't everybody. Okay, continuing on with my discussion of open clusters. So Gaia, as it looks at the sky, it doesn't download complete images. What it does is it identifies the stars seen by its detector and does a whole series of different observations of them. allowing us to figure out their color and their motions with never before seen, well, details. With observation after observation, as our own Earth goes around the sun and as Gaia goes around us, it's able to use parallax to also see the motions of the stars that are due strictly to our Earth moving around, causing nearby objects to appear to jump side by side to side, while more distant objects appear to stay stationary in the telescope's field of view. So with Gaia and this amazing ability to measure the radial velocity of stars as they move in and out of the sky, as well as its ability to measure astrometric motions in the plane of the sky and to use parallax to measure distances, well, we're able to put together super detailed understandings that allow us to trace out exactly which stars do and don't belong to the slowly deforming Hyades cluster. Now, finding lost things seems to be a theme for today's science. In other news coming to us from the SETI Institute out in Mountain View, California, we have new understanding on rocks that have fallen out of the sky. In this case, scientists are working to try and figure out which examples of meteorites that we've found have come from one asteroid or another. In this particular case, we have a tale of two meteorites that fell in California, one that fell in Creston and one that fell in Naviato, 200 miles to the north. Both of these meteorites on first look looked identical. Scientifically, they were both classified as L chondrites of type L6 and shock stage S3. What all of that translates into is they were essentially made of the same stuff and heated up the same way through all of their interactions. It was assumed that maybe these two identical looking meteorites that hit the Earth 200 miles apart rather, just might have come from the same parent object. Using mass spectrometry, we're able to take samples of meteorites and do an atom-by-atom comparison of their composition. And this has allowed us to figure out that some of the meteors we look at come from Mars. Some of the meteors that we look at come from Vesta, from Ceres. We're able to essentially use chemical fingerprinting to figure out exactly, well, what big rock all the little falling rocks have come from. Now, in looking at these two rocks, not only did they find that their chemical properties weren't identical, but they were able to actually figure out differences in when these small rocks that came tumbling down to Earth were formed. In one case, from looking at the chemical composition, they were able to figure out that the meteor that hit Creston had been in space and free from its parent body for about 45 million years. At the same time, the Novato meteorite appears to have been, well, freed from its parent body for only about 9 million years. So the reason I'm phrasing it this way is freed from their parent body is the different surfaces, the different compositions, the different minerals all end up getting changed when a asteroid undergoes a collision that causes it to fragment. Parts that are exposed to space undergo special processing, and that shock itself can create new minerals that are only temporary in how long they last. By comparing the specific composition of these two rocks from space, not only did they figure out that sometimes things that look alike are actually, well, made out of slightly different materials, but in this case, they actually also have different parents, different parent bodies. This also tells us some interesting things about the asteroid belt's history. It tells us that collisions and the formation of small debris is an ongoing process, that in this case, there was a collision as recently as 9 million years ago. Our views on exactly what the asteroid belt is have continued to change over the decades. It has gone from, well, this is a planet that was broken apart, to it's leftover debris from, well, material that there just wasn't enough to form a planet out of, to this was a whole bunch of dwarf planets, many of which collided together to form smaller and smaller objects. It's unknown if we'll ever be able to get a true understanding without having to go out and sample the composition of every single rock in the asteroid belt. But for now, we're getting pictures as we can by sampling every rock we can that hits the surface of the Earth. It's one step at a time, science, and it's getting the job done one step at a time. Now, in our final story of the day, I have a tale of a new nation going to explore other worlds. And this is the nation of Israel getting ready, and I have to release the puppy. Okay. Apparently, whatever caused her to be scared and dive into my lap no longer scares her. So our final story of the day is a tale of a little spacecraft that can. SpaceIL, an Israeli space consortium, has been working on building a lander to go to the moon for more than a decade at this point. Originally part of the Google Lunar X Prize competition, they have kept on going even after the competition ended. Today, they are waiting for launch. The spacecraft has been delivered. The press release has gone out. I personally awoke to hearing a story about SpaceIL on NPR, and I want to make sure that you all know where to go to get whatever information you may want on the spacecraft. And that place is SpaceIL.com. And when you go there, you can find out about their mission and how essentially they planned 3 different stages. First, to make a soft landing, then to essentially hop 5 meters over. This is part of the original Google Lunar X Prize challenge. And then they're going to send high-definition videos back to Earth. Now, the site has all of the information you could want professionally, with high-quality information describing the technology, the team. Everything is right there, and it's done beautifully. But my favorite part of this website is the SpaceIL kids. Part of what this team has been looking to do is make it clear to these kids growing up in a country that isn't really known for its space exploration that they are part of the space race. And with kids.spaceil.com, you have all sorts of cute things that you can get involved in exploring. And it's just fun. It's just fun. So go check it out. Get your kid to check it out. And remember that we're one people. We share one sky. And as Astronomers Without Borders teaches us, you can have star parties that cross all borders and boundaries. And it's all one science that we share. So that concludes my 3 news stories for today, with crazy puppy, scared insanity sneaking in. And I'm now going to take your questions. So go ahead and type those in, and please, please, please at CosmoQuest X when you do so that I can more easily find them in the chat. Now, while you're typing those questions in, I just want to remind you once again that the Daily Space is brought to you by CosmoQuest. We are your place to learn and do science. CosmoQuest is a production of the Planetary Science Institute, working in collaboration with Youngstown State University. Tomorrow we are going to be doing a special extended edition where we're going to be talking about something. And I'm trying to remember what it was that I promised what we were going to discuss. And it is completely gone. Mars 2020. We're going to talk about the Mars 2020 launch window and what you can expect coming up that next time we have a perfect alignment of Mars and Earth to allow us to get our spacecraft over to the red planet. So tune in tomorrow, get a dose of the news, and get an update on all that is coming in Mars 2020. So now to go ahead and take a look at your questions. So Crispy Fried Man asks, what's the difference between the process of things coming together to form larger objects and things splitting apart like our asteroid belt? Mostly it has to do with speed. If you collide two things together violently, they will bounce apart, and if they're brittle, they'll break apart in the process. You can try this with two things of Play-Doh rolled across the table. Roll them across the table, and they will splat off of each other. Actually, Play-Doh is probably a bad example. Do this with two magnetic balls. Roll them together, and if you roll them together violently, they will bounce off of each other, and the magnets won't have a chance to glom them together. Now, if instead things to come together more slowly, more gently, as we believe happened with 2014 MU69, they are able to merge together instead. So the processes that built up planetesimals eventually into planets were slower processes where things merge together more gently and we're able to build up. The processes that break things apart are much more violent. It also has to do with the angle at which they hit, how big they are, how much gravity is involved, what force is the greater force. So there's no simple answer, but I hope that gets you at a hint of an answer. So let's see what else is in there. Are the asteroids splitting because they're spinning themselves apart? No, Hannes Vorwerp. It's strictly collisional. Things hit each other violently and they hit each other violently and break apart. Let's see. Scrolling up. So Hannes Vorwerp also asks, what does SpaceIL plan to do after a successful landing? What was supposed to be the next step in the X Prize? So the X Prize Foundation sponsors lots of different competitions that don't just have to do with going to outer space. There is no X Prize currently slated for space exploration. And part of the reason for this is there was just too much instability in getting rockets that were able to launch. When everyone was at the whim of SpaceX and the other companies, that was just no longer a fair competition that could be extended and extended and extended. So SpaceIL continues to work on planning additional missions to go to outer space. They're working with commercial partners. They're working with government partners. It's all detailed on their website. And we also did an interview with Yov. I can't remember where. It was probably on the Weekly Space Hangout. If Susie is out there in the chat, if she can remember, hopefully she can put that up and you can see Yov Landsman, who's one of their engineers, actually talking about this directly. So Space Cowboy says, I don't know if they mention this, but do you know anything about the 79-foot asteroid that was discovered in January and has been skimming Earth's atmosphere? I know nothing about this. I know nothing at all about this. I'm going to have to learn about this. I'm sorry. The one that killed the dinosaurs, the asteroid that killed the dinosaurs would have been bigger than 79 feet, though. 79 feet will do a good bit of damage, but in the grand scheme of things isn't that big. So Hanus Warverp is asking, so will Gaia be able to tell scientists if a specific star goes supernova? If it's one of the stars in the field, yes. So it's actually easy to tell with even Earth-based telescopes that do regular scans of the sky. That supernova from a nearby system can be matched with this star that was observed earlier. Unfortunately, in some cases, the supernova we see are originating in galaxies so far away that the parent galaxy is just a smudge on the sky. So this is where I'm a little hand wavy in the answer. If the star that goes supernova is near enough to be seen as an individual star, to be resolved is a scientific term, then yes, Gaia and any other telescope looking that direction will be able to associate the star and the supernova. But if the star that explodes is too far away to be resolved separate from the rest of the galaxy, it can't help us. Let's see what else. Oh, so many of you have Monday off. I have so much envy. So Veronica Cure is asking, is Yov the one who presented at the eclipse meeting in St. Louis? Yes. And it's Y-O-A-V. You can't hear the A. But yeah, he's the one who presented, and his wife and his adorable children were here with him. So I think that's all the questions for today. Yes, Arnster's right. There have been a pair of potential craters found underneath the Greenland ice shield using new techniques. And the reason I phrase it as potential is it's not like we can dig under the ice and make sure that the land is shocked identical to the way it would get shocked if they were impacts. But everything looks like there are 2 impact craters hidden beneath the ice in Greenland. Yeah, all is good. Well, if there is no more questions, I am going to work on, no, they're not bigger than the Chicxulub crater, Larry. They are perfectly reasonable sized craters. Chicxulub is like an entire bay, basically. Yeah, Hanny's Reverb, it's hard to know exactly what geological figures are hidden beneath the ice of the world. Let's hope we never find out. Let's leave some of that ice there. Anyways, I'm going to move on to working on getting a bunch of research tasks done and telecons and all the other horrible things that are less interesting than talking to all of you. So for now, I'm going to say thank you all for being here. Thank you for supporting us. Your subscriptions, your bits, all of these things are what allow us to be here day after day. We bring you the Daily Space every Monday through Friday, more or less, at 1 p.m. Eastern. That's 10 a.m. Pacific, 6 p.m. London time. Thank you, Skyfro, for the follow. Skyfroy? I'm not sure how to pronounce that. Thank you for the follow. We are made possible by you. Tune in and give us a follow. Follows are free. You just had a great example of what they look like, and it'll allow you to know when we go live. In addition to the Daily Space, we also bring you a variety of launches, landings every Sunday. Our own Annie Wilson, Binary Ablaze, does Sunday Science Hour. We are here for you, and we are thankful that you allow us to be here. So, thank you. And I'm going to go ahead. I'm going to roll the credits. And after I roll the credits, we are going to raid someone. Not sure who to raid. Who should we raid? It's making no suggestions. trying to find where my chat went. So we are part of the Knowledge Fellowship, and in general, when I look for people to raid, I am looking for other scientists who stream. So right now I'm looking to see who else in the Knowledge Fellowship is out there and streaming. It looks like we are going to have, thank you so much, Canada Kim, for the bits. It looks like Adam13531 is going to be streaming coding. And so we will raid over to Adam after the credits. So thank you all for being here. And wherever you are in the world, have a fabulous morning, evening, or afternoon, and get outside and look up. Bye-bye.